Mr. Mathias Riggenbach. He is Head of Product Management, Drainage and Supply Systems from Geberit International Sales Company. He came from Switzerland for us, and he's going to speak about an interesting topic called acoustics in plumbing piping system. And we are looking forward, and we'll come now to fix the presentation.
Sorry for missing the first part, but anyway, I think I fit more into this part. But it will not be so in details. Okay, thank you very much also for the invitation and to give me some time to speak here about a bit a different topic, about plumbing in piping systems. I go through the agenda quickly, we'll talk a bit about the basics, and then also we'll go into the acoustic regulations, acoustic data, and have a small summary at the end of the presentation. So maybe as we talk here much about HVAC system, just to remind about which decibel level we are talking here when it comes to plumbing noise in residential house, offices and so on. We talk about levels between 20 and 30 dBA. So I guess this is a bit different to the HVAC system, which normally are on a higher scale. So here we concentrate really on levels below or on 30 dBA. Also, we talk much about the airborne and structure-borne sound. So in the installation room, where we have the toilet, of course we have airborne sound. So if you flush the toilet, we hear the toilet. This is also needed, so we know the toilet works. And the regulations are not according to your own room or your own home. You should not get disturbed by your own flushing of the toilet. Otherwise, maybe you should go to the doctor presentation, you have some other problems. But what is important are the other rooms, so the neighbor rooms, of course also not your own rooms. And then we talk mostly about structure-borne sound. So sound which is going over the structure of the building, especially when we talk about solid installations, so concrete blocks and so on. And when it really goes to acoustics, we are talking mostly about gypsum walls, about lightweight walls, to really make sure we do not have any acoustics traveling to other flats or offices. How reduce airborne sound? I think it's quite easy also. We do encapsulation, so we have all the ducts, so mostly anyway the drainage pipes, they don't look so nice. We put them behind ducts, but the main reason is to really keep the airborne sound out of the room, to make sure all the sound produced is not spreading as airborne sound in the toilet. Then as well, also the solid-borne sound, we have the special brackets. So I think the same on the HVAC system, we have this rubber on the channels which you connect, and you deconnect also all the installation from the building. And this is actually the same in plumbing industry. So we really have to detect all the devices from the building. I always say all the installation should be like floating inside the building. It should never be fixed to the building itself. Because then we have the big problem of this solid-borne transformation of the sounds. So I'm sure everybody knows if you have, for example, a heating pipe, you hit it on the first floor, and you have no decoupling, no rubber brackets, then you will hear it even from the first floor to the 10th floor. And exactly this we want to prevent. Also, what we use in practice, we use in Switzerland, we put the pipes in concrete. It's very special to Switzerland, to the Netherlands. In South Africa they also do it, so they use the HDP pipes which they use in concrete, and also there we have of course to decouple it, and we do this with the rubber mats. We use the same as a bracket to decouple it from the whole environment. So what is mostly happening in reality, wastewater noise is neglected in planning. So as well here, if you don't do a proper planning, you will have much problems later on, and then it will be very costly to change them. Once you have something behind the duct or even inside the concrete, the pipe, imagine you forgot the insulation, you cannot just put it afterwards. There's a very cost-effective way, it's called the compressor machines, which you have to use, and this of course is very costly. Or then also the people, when they realize maybe about the sounds they are already living in, they will have to go to a hotel or somewhere else to make sure that we can make everything right. Then also installation elements, they have direct contact. So you see the installation elements, so floor standing toilet for example, which here also in Greece so is not much used anymore. Also here use the floor or the wall mounted toilets, and then also we get better acoustic values of course, if the sound doesn't go to the floor but then to the neighbor. And then also some drainage pipes do not absorb the noise. Of course also the pipe is important, but I would say the pipe is maybe 10 or 20% of the whole problem. I will show a bit what you can do to really make sure you get already a good acoustic insulation without using even expensive material. Also here we see some different installation methods from different countries. So also here, as I'm coming from Switzerland, we mostly use, as I said, the cast in concrete concept, but I work in the Middle East and African part, so we have many times cross-floor installations. So also here you see there's a direct sound produced to the neighbor, so not very useful. So here we say to make some sound measures are very difficult or very expensive. Of course here you could put a very expensive lower ceiling, which is done many times in some countries, but I don't go with the pipe on the upper floor or in the concrete or even on the upper floor. Or at least what we try to go with the toilet on the upper floor, when you have a wall-hung toilet, that's easy possible, and make sure the toilet is the loudest device always, because we have a lot of water coming in a very short time. So mostly the toilet is the most, the device with the highest noise. So also installation habits are very important. So already there, if you do a proper planning, a proper installation, you can prevent already a lot of acoustics going to the neighbor flats. Also here, for example, what is done many times also wrong here, we have, for example, installation of a toilet directly to the wall of a sleeping room. Still, of course, here there are no regulation in your own home, but of course it's also pleasant when you have a nice installation in your own home. And if you have it, for example, to the neighbor, then it's even worse. So we try mostly to do this to the staircase or to another room, which is not relevant for the acoustics. And then also here, for example, a duct which we produce. So always when you do a duct, actually we increase the noise. You all know if you are in a smaller room. Here in the big room I need the microphone. If you are in a smaller room I don't need any microphone. We increase the sound. So also here, just with insulation on an L-shaped base, we can break the noise and already make it quite a good acoustic installation. So also you see here, planning is crucial when you talk about acoustics. I think that's also in the ASHRAE installation, it's exactly the same. So if you do a good planning, a reasonable installation, you can already get very good acoustic results without using expensive pipes or other devices. Then also the different room types. I spoke already a bit. For example, all the toilets, mostly the installation, for a good hydraulic installation, you have the bathrooms on top of each other. And there are no values regarding acoustics to the neighbor bathrooms. So there, normally in the bathroom you are loud, you're doing something, and then the noise is not really important even in the neighbor's bathroom. Of course, in your living room and especially in your sleeping room, they are the critical rooms, and there you have to take care. So you see here, we always have to think three-dimensional when you talk acoustics. Because your own rooms, again, they do not matter, they don't have, well, they have some standards I will show you, but mostly for the general acoustic standards, there's no rule in your own rooms. Of course, if you really want to achieve high acoustic insulation, you can also request for this. Then, what should be used also mainly in the plumbing industry. As I said, it's always thought, people think about the pipe, so I will show you some examples, some standards which are only about the pipe. but what is important, we always have to think about the whole installation wall. So all the devices which belongs to the plumbing, they have to be considered to do a good acoustic installation. So as I said, all this wall here is a kind of a pre-wall. You see there's an insulation here, and it should be detached to the normal wall. And this also helps for the statics. So sometimes they use this wall, they break it, they put the devices inside, so it also has additional benefits on the statics of the building. Especially on new buildings, building walls and breaking it afterward also doesn't make too much sense. So to work with a pre-wall, also make sure you get the best acoustic results. As well, the wall-hung toilets here, I mentioned already, of course much better than a floor-standing toilet. You keep the noise in your own room and do not send it to the neighbor's room on the lower level. And of course, pipes still are important, but I would say if you have a normal pipe, you make a good layout and then also good installation. You consider all these points, the whole system, you will already get very good acoustic results. And if you really want to achieve the high results, which I show you afterwards, of course then you need also special pipes, special material, and a bit more special way of installation. Here, just some example, also some offsets here which we have in the pipe, they can create a lot of noise. So you see, for example, a 45-degree offset can create already +9 decibel, which is quite a lot. When we talk about acoustics, if we go 30-degree offset, we have only 7, and if we go for a 50-degree offset, we are only on +5 decibels. So best is not to do any offsets, also from hydraulic point of view, but more also from the acoustic point of view. Responsibilities, also a big point. Who is responsible for the acoustic in the building? There are always some, let's say, the engineers, of course, the architect who makes the previous layout. So I always say the escalation rate is already starting here. If the architect makes a bad layout of the building, for all the others it will get very difficult to repair this bad design. And many times also I see architects are not aware of all these measures they can do because it was not really taught to them in the school. And this is also something which I think is important on the acoustics, also to talk to the architects and show them really how to do it right. And maybe also here to explain a bit how it started in Switzerland, why this acoustic got important. It was mainly because of the insulation of the building. Again, I come back to the general topic of the conference, to decarbonization, difficult word. And we started to insulate and insulate more. I have seen this morning, the colleague showed one insulation of 6 centimeters. In Switzerland, already 20 years ago, we started to do 20 to 25 centimeters of insulation on the building. Because we could see that with this input, we can reduce the carbon output very drastically. Of course, there's a limit then. Also, we checked a bit how much really makes sense, and I would say between 20-25 centimeters really of using insulation makes sense. And at this point, what happened? We used triple glazing window as well, so we renovated the facades, and people inside, they got it more quiet as well at the same time, but they started to hear other noises. So here you will see that also on the regulations, they are mostly focused on Central Europe and not on other countries. And this is a bit the reason, because if you have bad windows or a low quality facade, if you do not have this cold weather, you don't need this extent of insulation or triple layer windows. And once you do this, the inside noise will get louder. So we did a lot of renovation at this time, and then people started to complain about the toilet flush. Before they didn't hear it, they hear the cars in the streets, they hear the planes or whatever which is outside, but not the inside noise. And this is also a bit, I think, what is important for the future, what you are doing in Greece. that more you put more insulation, you take more care to keep the cold inside the building, and actually it's the same effect. If you want to keep the warm or the cold inside the building, you will make the building more silent inside. And people will start to complain about other things. So it's a bit a stone which started to roll also in Switzerland. And then we started also, of course, we had to pay attention to this. We made norms, we made regulations, we had to teach the installers and so on and so on, and they took over the responsibility. And the first ones who were, of course, inside this cave to close the loop were the architects. So they really have to do the first drawing of the building in a good way, to think about also where's the toilet, how are the installation, to make sure all the following people can go for the proper installation. Then the planner, of course, definition of the installation walls, sound specialists if they are available, and then also very important, we all know, everything fails with the installation. If installation is not done good, you can have the best product. If you don't install it good, all the benefits will be lost. So I see I have to speed up a bit. So here I show you some standards. So you see German standard, Swiss standard, Austrian standard, we have a UK standard. We have also in Israel we have a standard, but other European countries, they either use the German standard, which is mainly used also in hotels where it's mostly important. And there's the EN14366 standard. And it's very important here, on these standards here we define acoustic values within buildings. So very easily said, when you are having a nice dinner with your family and the neighbor is flushing the toilet, we measure the acoustic value which you hear in your building. And this is what you matter at the end of the installation. So this is important, okay, I want to hear below a certain value, to have a comfortable life, to not get disturbed by the customer, and by the neighbor, and then I would say this is the important point. Unfortunately, this standard here, the 14366, was also, or is mainly used in the Middle East and African region. And here they measure some standard installation with wastewater in the Fraunhofer Institute in Germany. I'm sure you all know Fraunhofer Institute. And this is more just to differentiate some pipes. So they only measure some pipes. And it's not really important value for the end user who is, for example, buying an expensive flat. He doesn't care what they measure in Germany somewhere in the laboratory. Here, an example also of the British standard. Also here, it's not really much defined. We have, of course, values here from 7 to 23. Then also in the night, some other values around 35 to 40 dBA. But also what you can read here, and what is a bit the missing part in most of the acoustic standards, it's not giving values for solid waste pipes. You see here in H4, for example, it's only written noise emission from hydraulic systems, blah, 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 blah. Other bedrooms is not to cause disturbance in normal use. So what is disturbance in normal use? Everybody has a bit different perception on disturbance, and that's why, of course, we need some regulation on decibels. So we need exact values, and we do not need just some vague interpretation from any standard. So we really need to have this clear. So this on the British standard is a bit difficult. I show you, for example, DIN 4109. Here it's clearly defined for living spaces and bedrooms. Clearly diagonally, you should be low on 30 on lower, or classroom and office spaces in 34 decibel A. And then also you see in vulnerable room in Asian area, there are no requirements. So this is the 41091, and then we have the higher levels for the 4109, where you go even on the lower level. So this is standard here, you have to do it in all the houses. This one here is optional. If you say I build a very prestigious property, I want to take this into the contract, so you have to define these levels. So the DIN EN44, as I said, This is more for defining installation of pipes, which I show you. I will not go through all the points here, as there's no time. You see here in this institute in Germany, they measure here on the second floor, they put in the water, and then they measure it 2 floors below. So here we get really low values, even below 20 decibels, which are not important if you make an installation in this room here, and then you measure, for example, the diagonal noise. Also here they use some special installations, also some very thick walls here, and this is just not reflecting the reality. It's what they do in a laboratory, and of course you get some values, but they are not suitable for installation in the reality. So what should be done according to DIN 4109? Taking real installation, flushing the toilet, the loudest device, and then measure directly in the different rooms which are near to you. Because those are the values which are important when after you, for example, buy the flat, you make a measurement, you want to see this value on your value equipment, and you don't want to see any value from a German laboratory which was measured under laboratory conditions. So here the difference, you see EN4366 is a let's say a cost-effective way of keeping customers happy, not giving them practical values. And then DIN 4109 is a rather expensive way. You have to build up many different situations, so it's not a predefined situation in a laboratory. So many different situations which you can have in your country, for example, build them up, making measurements, making certification, etc. So this one here, of course, helps the industry. This one here helps a bit to keep the cost low, which is not in the interest in the end of the end owner who buys property and gets a certain value guarantee. So there are measurement data for common situations here. You see, for example, an example of a drywall system. All the devices are built up. Everything is clearly defined. How is the installation? How it will be done also after on the building side. And then you get a measured value up to 25. If you are below, it's okay. You should just not be over 25 people. Installation, I already said, mostly it looks like that, unfortunately, when you have done all right. Of course, also here it's important you decouple everything from the building. You see, for example, this metal bracket here, direct contact to the wall, so the sound will be spread over the whole building. Also here, there's no insulation between, so all the sound will be spread over the full building. So I come to the summary. Nobody cares about drainage until it becomes a problem. So you do installation, you do. Somebody goes to live in, starts to complain, and then it gets expensive. Design with acoustic in mind from the outset, so that's the advice I can give. So if you do that, you can be sure you will not have any problems also with the customer afterwards. Ensure good installation practice, and if you get this EN certificate, make sure that also if they promise you some low levels below 20 dBA, that you get this signed from this planner or whoever offers you these low values, because we know, I'm sure also you know, below 20 dBA to achieve something in a building is very difficult, to not say impossible. So that's it, in a very short way, a bit excursion to the plumbing industry and to the challenges we have there when it comes to acoustic. Thank you very much for your interest at this late time, and thank you also to ASHRAE for the...
Thank you, Mathias. It's not exactly a question, but you mentioned about the insulation in Switzerland being from 20 to 25 centimeters. This is something very difficult to happen here in Greece, for example, because if you insulate a building with a thickness of 20 centimeters, then the internal loads in the summer period will be like a hell in the house. So it's something different in every climate.
Yeah, I disagree, because in Greece, what you do on the fridge, you also insulate the fridge, right?
Yes.
to keep it cold inside. So actually, it's the same concept.
But what about the internal loads, like lighting, like the people, like the television, the computer? If we have loads in the house not coming from outside, not talking about gains from the environment, I'm talking from the internal loads, then you cannot take them out from the house.
Exactly, but this is the period you cool down. I mean, you cool down in summer.
You had the same problem, as you said, with the insulation of the noise. If the insulation of the noise was too thick, then you had a problem because it was trapped.
No, the problem was at one point it doesn't make sense to put more insulation. It's a ratio of investment and turn back.
Okay.
That is the problem. Sorry, sorry, there was a misunderstanding. So we went to 30, 35, 50. You know, also for example the water heater. There's a certain, let's say, insulation which it makes sense. And the more you put, at one stage it doesn't make sense. You don't save much more. That's what I wanted to say.
Thank you very much, President.